Okay, so here are athletes. We know that there's a probability that they took drugs. That's given to us as 0.02. Therefore, we can figure out the probability that they did not take drugs is going to be 0.98. Now, we further know that given that they take drugs, the probability that they're going to test positive, given that they took drugs, is going to be 0.95, because we figure that's the converse of the probability that they did not test positive, given that they took drugs. That's also called a false negative. The probability, on the other hand, that they tested positive given that they did not take drugs, which would be a false positive, we know is 0.01, and the probability that they did not test positive given that they did not take drugs, which hopefully is most of the case, is 0.99, which is good to know. Now, we could multiply through. When we want to figure out what's the probability that somebody took drugs and tested positive, well, we're going to do 0.02 times 0.95. Okay, that's going to give us if they took drugs and they tested positive, and that is going to actually equal 0.019. Sorry, it gets a little squishy in here. You're going to do the same thing for this. So this is going to be the probability. You can multiply this through. The truth is we're actually not interested in that, because what I really need to know is the probability that somebody tested positive. How do I know that? That's going to be over here, that the probability that they tested, I multiply it through the same thing, that's going to be 0.01 times 0.98. And that is going to actually give me 0.0098. Okay, so somebody who tests positive and did not take drugs is only going to be 0.0098 of those 5,000 athletes who are tested, which is actually very, very good to know. So if I wanted, therefore, to go ahead and further, I could say, well, I need to know at this point, I need to know the probability that somebody tests positive actually took drugs. That means given that they tested positive, what's the probability that they took drugs? And we know that that's going to be the probability, by definition of conditional probability, that's going to be the probability that they took drugs and tested positive divided by the probability that they took, that they tested positive. We know from beforehand that the probability that they, if I added those two figures together, 0.019 plus 0.0098, I get a total of the two different ways that somebody could test positive that we just did on the last slide. That's going to be 0.0288. And we know from the previous slide also that the probability of taking drugs and testing positive is going to be 0.019. And if I calculate that out and I divide it, I get 0.6599. So that is going to be what is the probability that somebody took drugs given that they tested positive. That is the way of doing Bayes' law that you could do without actually doing Bayes' law.